All right, let's dive in. We're tackling self-curing dental resins today, specifically this new Stela Automix. Our listeners sent in some research, so, well, let's see if it's as amazing as everyone's saying.
It's definitely a hot area in dentistry right now. Lots of innovation, especially as we move away from those old amalgam fillings.
Yeah, for sure. And, I mean, light-cured resins have been the go-to, but they've got those limitations, right? The research you sent over really highlights the whole struggle of getting enough light to cure those deep cavities the right way.
Oh, absolutely. And if you don't get that curing depth right, it can cause some serious problems down the line.
So break it down for us. What happens when that resin doesn't cure all the way?
Well, you're looking at a filling that might not be as strong, could wear down faster. The bond to the tooth can weaken too, so it's more likely to, well, fail sooner than it should. And dentists, let me tell you, replacing these failed restorations, huge part of their work. More than half, actually, if you look at the research.
Wow, over half. That's wild. So where does steel Automix come in? It's supposed to be this amalgam alternative, right?
That's right. And the idea is to get around some of those light curing issues. Since it cures on its own, no light needed to harden. So potentially it could cure to any depth, solves that whole problem of reaching into those tiny crevices.
Sounds pretty promising.
Yeah.
But let's dig into the study itself. What exactly were they looking at?
They zeroed in on Stela's degree of conversion, DC for short. Basically, it measures how completely the resin sets. They use this technique called FTIR spectroscopy to analyze it. Tested Stela in a few different ways.
Wait, back up a sec. FTIR spectroscopy. Care to give us a quick explanation? Some of our listeners might not be familiar.
Sure thing. It uses infrared light to identify the chemical bonds in a material. So in this case, it showed their researchers how well Stela was polymerizing or hardening, under different conditions.
Okay, that makes sense. So different ways of testing. What were they and what they find?
Well, they looked at Stela by itself, then with its special primer, and then with a common bonding agent. And what's interesting is with that dedicated primer, Stela's DC was way higher, like reached 72.4% at a depth of 2 millimeters, significantly higher than when it was on its own.
That's a big jump. So this primer seems pretty crucial.
Seems like it, yeah. Like there's this synergy between the Stela resin and the primer. It really boosts that curing process.
The research mentions how fast the reaction happens, less than a tenth of a second. Makes you wonder if adding light would even matter.
Funny you should say that. The researchers looked into that too.
Oh, really? What'd they learn?
Well, they zapped Stela with light for 20 seconds, and guess what? Didn't really improve the DC compared to just using the primer.
Huh. So the light was basically useless? Surprising. I always figured more light meant faster, better curing.
Not always, no. And there's another thing to consider. Temperature changes during curing can affect how comfortable the patient is, and if it gets too hot, it could even damage the tooth pulp.
You definitely don't want to be cooking the inside of someone's tooth, that's for sure.
Right. And they were very careful about monitoring those temperature changes. Found that, yeah, light did make it hotter, but it also took way longer to cool down, like over 2 minutes. That kind of heat hanging around for that long could definitely cause some damage.
Makes sense.
Yeah.
The study even mentioned how going above a certain temperature could cause irreversible damage. So even though we think of light as fast and efficient, there are definitely trade-offs.
Oh, for sure. And this is where self-cure resins like Stela might actually have a leg up.
Oh, really? How so?
Well, because they cure slower, it could actually mean less shrinkage stress during the whole process. And that shrinkage stress, that's what creates those tiny gaps between the filling and the tooth, which is obviously not ideal. In fact, this study showed that Stela adapted to the tooth much better, no gaps, even after a year.
So better curing depth and less gapping. Seems like steel is 2 for 2 so far. Now, something I'm really curious about is where does this curing reaction actually start in Stela, and why does it matter?
That's a great question. It's kind of what sets Stela apart. Unlike light-cured resins, where it starts at the surface, Stela's curing actually starts at the walls and bottom of the cavity, right where the primer makes contact.
Hold on, so it starts from the inside out. That's wild.
It is, right? And get this. The researchers were even able to see it. Use thermal imaging to capture that curing pattern. Pretty cool stuff.
Okay, so inward-out curing. Help me understand why that matters for how well the filling works overall.
Well, picture this. When it starts curing right where the tooth is, it's like it's creating a much stronger bond right from the start.
Like building a foundation from the ground up. Make sure it's solid and sealed tight.
Exactly.
It really does seem like steel has got a lot going for it. But what about the long game? Is there any data on how it performs over time.
That's the million-dollar question, isn't it? And yeah, we definitely need more research there, how it holds up to wear and tear, staining, keeping that smooth surface. All important for a filling to last.
For sure. Lab results are one thing, but how does it handle the real world, right? What about that shrinkage stress we talked about? Even if Stela has less of it, is it still something to worry about?
Well, it's definitely something to keep an eye on. Even a tiny bit of shrinkage can affect the filling over time. So yeah, more research to really nail down how Stela behaves there.
Makes sense. What about bond strength? We know the primer helps with the curing, but does that actually mean a stronger bond between the resin and the tooth?
That's another big one for future studies. Will it hold up under all that chewing and biting for years and years? We need more data before we can say for sure.
So exciting early results, but we're not crowning Stela the king of fillings just yet. Need to see how it does in the long haul.
Exactly. But it's definitely a step in the right direction. And actually, speaking of promising, there's this other detail in the research that caught my eye. It's about what's in that Stela primer.
Hmm, interesting. What'd they find?
It doesn't have any tertiary amines.
Tertiary amines. I'm not sure I'm familiar with that term. What are they and why does it matter?
So they're these compounds often used in light-cured resins to speed up the curing. But the thing is, they've been linked to some problems, especially with the color changing over time.
So the fact that Stela's primer can get that fast curing without those tertiary amines, that's a plus, right?
Could be, yeah. It suggests that Stela might avoid those downsides, keep looking good for longer.
Okay, let's recap. We've got a self-curing resin, great curing depth, minimal shrinkage stress, cures from the inside out, and a primer that works without those potentially problematic tertiary amines. That's a lot.
It is. And this research, it's really making us rethink some of the old ways of doing things in dentistry. Like we usually assume light means faster, better curing. But the study shows that's not always the case.
Right. It's a good reminder to stay open to new ideas. Sometimes the biggest breakthroughs come from questioning what we think we know.
Absolutely. And it brings us back to that whole thing about where the curing starts. It's a big difference between Stela and those traditional light-cured resins.
Right, right. Stela cures from inside out, starting right where it touches the tooth. But remind me, how does that compare to the light-cured ones?
So with those, the reaction starts at the surface, where the light hits it, then works its way down, top down versus Stela's inside out.
And we talked about how that inside-out curing could be the key to minimizing those gaps, right?
Exactly. Since it starts curing right at the tooth, it's almost like it's hugging the tooth as it hardens, making a super tight seal. It's a totally different way of looking at it.
It's amazing how that one little difference in curing can make such a big difference in how well the filling works and how long it lasts.
It really shows how important it is to understand all the little details of these materials, how they behave at a microscopic level. Those tiny things can make a world of difference in the long run.
You're absolutely right. And this reminds me of something we touched on earlier about the composition of Stela Automix itself, specifically that GDMA ingredient. Can you remind me why that's so important?
Oh, sure. GDMA, it's a type of monomer. It's known to really boost the properties of dental resins, makes them stronger, tougher, more resistant to things like water absorption. It seems to play a big role in how well Stela performs.
So it's not just filler, it's a key ingredient that gives Stela some of its superpowers.
Right. The researchers specifically called out GDMA's role in helping Stela reach that high degree of conversion and cross-linking. Basically, it means it sets more thoroughly and forms a stronger structure.
Sounds like a lot of thought went into designing and creating this material. But even with all these potential pluses, I'm guessing there are still some downsides, some areas where Stela might fall short. What are some of those potential drawbacks to keep in mind?
True, nothing's perfect. One thing that needs more study is how smooth and shiny Stela's surface stays over time. Some early studies hint that it might not keep its polish as well as some of those light-cured composites.
So looks could be an issue, especially for people who want that super bright white smile. Anything else?
Some dentists have said that Stela can be a little trickier to work with than the usual composites. Might take a bit of practice to get good at shaping and contouring it.
So a learning curve for the dentists. What else?
Well, there's the cost factor. New tech usually comes with a higher price tag, and steel is no different. More expensive than the regular composites, which could be a problem for some patients.
Yeah, that's a real consideration. Accessibility and affordability are huge when it comes to new dental treatments. So it seems like Stela, while innovative, isn't a perfect solution. But hey, it's early days.
Absolutely. And researchers are working hard to address those limitations and make Stela even better. New formulas, techniques, tools to make it easier to use and better looking, all while keeping those great curing properties.
It's great to hear that they're dedicated to improving it. Shows how science is always moving forward, pushing the limits. And for dentistry, Stela is a big step forward. Potentially means faster, more comfortable, and longer-lasting fillings.
Couldn't agree more. This research really gives us a peek into a really exciting future for dental care.
And speaking of exciting, I want to bring it back to one of the most fascinating parts of this research, how that unique curing pattern, starting right at the tooth, could affect how long the filling lasts and how well it works overall.
Yes, it really gets you thinking about the whole curing process, not just the final product.
Totally. We tend to fixate on the end result, but how it gets there is just as important.
For sure. And with Stella, the fact that it starts curing at the tooth, that could have big implications for how it performs over time.
I'm all ears. Tell me how this inside-out curing could impact the filling's lifespan.
Okay, so think about a traditional light-cured resin curing from the top down. As it shrinks, it's pulling away from the tooth at the bottom of the filling. That creates stress points, those tiny gaps that can weaken the bond.
Like building a house on unsteady ground.
Exactly. But with Stela, it starts curing right at the tooth, so those shrinkage forces go outward, away from the bond. It's like it's gripping the tooth as it sets, creating a tighter, more secure seal.
Oh, I see. It's like a self-reinforcing mechanism, minimizing the risk of gaps and creating a stronger bond.
Exactly. And this unique curing could be a major factor in why Stela has the potential to last longer, meaning fewer failures and fewer replacements down the line.
That's a game changer. It completely changes how we think about fillings. Instead of worrying about shrinkage pulling the filling away, we've got a material that actually embraces the tooth as it hardens.
It's a pretty remarkable concept, and it shows how understanding the subtleties of material science can have a real impact on practical applications like dentistry.
It also reminds us that innovation is often hidden in the details, in questioning our assumptions and finding new ways to approach old problems.
Couldn't agree more. Stela is a great example of that innovative spirit in dentistry.
This deep dive has been incredibly insightful. I'm really excited about the possibilities Stela Automix holds for the future of dental care.
It's definitely been a fascinating journey exploring the research with you.
Before we wrap up, I want to touch on one last thing. You mentioned earlier that the research on Stela is ongoing. What are some of the key questions scientists are still trying to answer?
One of the big ones is understanding how that unique curing pattern affects the stresses inside the material itself long term.
Internal stresses. That's interesting. Tell me more.
Okay, so picture those traditional light-cured resins curing from the top down. The shrinkage forces are all going in one direction.
Okay, I'm with you so far.
And that can create a lot of stress inside the material, making it more likely to crack or develop tiny fractures over time.
Ah, I see where you're going with this. So with Stela curing from the inside out, could those stresses be spread out more evenly?
Exactly. That's what they're looking into. It's possible that this unique curing pattern could lead to a more balanced distribution of stress within the material.
And if that's the case, it could make Stela even tougher, less likely to develop those internal weaknesses that cause problems later on.
Right. It's a really fascinating area of research. Could have major implications for how durable and successful Stela restorations are in the long term.
It's amazing to think that something as simple as the direction of curing could have such a huge impact. Really highlights the complexity and elegance of material science, doesn't it?
Absolutely. And this is just one of the many questions researchers are eager to answer as they continue to study Stela. They're also looking at its resistance to wear and tear over time, how well it resists staining and discoloration, and how it interacts with different types of tooth structures.
It sounds like there's a whole lot more to learn, and I'm really looking forward to seeing what they discover. But even now, it's clear that Stela has the potential to revolutionize how we approach dental fillings.
I couldn't agree more. It's a testament to the power of science to keep pushing the boundaries of what's possible and improve patient care. And this deep dive has been a great opportunity to explore those possibilities.
It really has. It's been a thought-provoking journey into the world of self-curing dental resins, and I feel like I've learned a lot.
Glad to hear it. It's always a pleasure to discuss these exciting advancements in dentistry.
Before we sign off, I want to thank you for being our expert guide on this deep dive. Your insights and explanations have been invaluable.
The pleasure was all mine. I'm always happy to delve into the science behind these cutting-edge dental technologies.
And to our listener, we hope this deep dive has given you a better understanding of Stela Automix and its potential to change the world of restorative dentistry. As research continues, it'll be fascinating to see how Stela evolves and what other amazing possibilities it unlocks. Really makes you appreciate all the work that goes into these new materials. We've covered a lot of ground, from those issues with traditional resins to all the unique stuff about Stela Automix. Feels like we're on the verge of some major changes in how we do fillings.
I think you're right. It's a really dynamic time for the field, and Stela is a perfect example of that.
So as we wrap up, is there anything else you think our listeners should keep in mind as they, learn more about Stela and all these advances in dental materials?
I think the biggest takeaway is that this is just the beginning. We're still early in the research on Stela, lots more to learn. I'd encourage everyone to stay curious, see what else comes out about it.
That's great advice. Easy to get swept up in the hype of new tech, but science is always moving, always changing, right?
Exactly. And I mean, as people who are learning about science, we need to think critically, really look at the evidence.
Absolutely. Ask questions, look at things from different angles, be open to the idea that what we think is true today, well, might not be tomorrow.
That's what's so great about science. It's all about discovery. And when it comes to our health, it's definitely worth it to stay informed.
Well said. It's been a pleasure getting into all this Stela Automix research with you today. Thanks for sharing your expertise.
My pleasure. Always happy to dive into the science behind these cutting-edge dental technologies.
And to our listeners, we hope this deep dive has given you a better understanding of Stela Automix and its potential to change restorative dentistry. As the research continues, we'll be watching closely to see how Stela develops and what other exciting breakthroughs are on the horizon. Thanks for joining us, and until next time, keep those minds curious.